Hi, my name is Carlotta A, and I'm a professor of electrical and computer engineering and robotics, and I'm also an open source hardware trailblazer fellow. My project is Robotics for the Streets, robots for academics to engage in service, teaching, and learning. And I have created the flower bots, Lilybot, Daisybot, and Rosybot. Lilybot is my smallest robot and is used for service and outreach as well as for high school robotics. Daisybot is my next largest robot and it's used for high school students or perhaps freshmen in college to engage in learning a little bit about STEM and robotics. And Rosybot, which is my research platform robot, which will be used for upper level undergraduates or graduate students to engage in mobile robotics research. Today, we are going to do light tracking on Daisybot by adding a photoresistor and a 10 kilo ohm resistor. Please come along and I hope you enjoy and stay STEM-tastic. So here we have the photoresistor right under our motor controller, and what you'll see is that one side goes to 5 volts. The other side goes to the 10 kilo ohm resistor that's connected to ground, and at the meeting point of the photoresistor and the 10 kilo ohm resistor, it goes to pin A0, which will read the photoresistor. So here's the photoresistor wired to our breadboard. So here's the motor controller, the photoresistor going to 5 volts, the 10 kilo ohm resistor going to ground, and then this yellow wire that comes from the meeting point between those two that goes to A0. So here's the Daisybot light tracking code. We will highlight the parts that are new for this code. To learn how to use some of the other parts of the code, please see the sound, motion, or range sensor videos. So for this one, the new information will be our photoresistor. So the first thing you should note here is that the photoresistor is attached to analog 0. Then we have a global variable ambient light, or if we want to set a max light variable of 900, we can set that as well. And those are used to detect when the robot should stop moving and start moving. Next, if you go down into the setup function, we are going to have a pin mode for the photoresistor, and it is set as an input variable as shown here. Later in that same setup function, we read the ambient lighting in the room and we set that as ambient light so that we know this is the threshold for when the robot should not move, and it should only move when it exceeds this value. Then we have the robot begin to indicate that the robot will start moving. In the loop function, we then have a switch to read when the robot is on or off, and we have the analog read to read the current photoresistor lighting. If the robot is on, we read the light and then we map that light to the ambient and max light for when the robot should move. So ambient is the room lighting, max is from my cell phone, which is the range from 0, not moving, to 255, the maximum speed on the robot. And then just to make sure we don't get any values outside of the acceptable speed range, we constrain the speed to be between 0 and 255. And then the robot moves in reverse based upon that speed, and it continues to read the switch to know when to turn the robot off. Now let's take a look and see what this looks like on the robot. Flipping the switch, and nothing happens because it does not detect more light than the ambient. So if I use my cell phone light, the more light, the faster the robot goes, and as I take the light away, the robot slows down. If I take it totally away, it goes back to 0. So the light is proportional to the robot. And since it's in reverse, this would be an example of the robot being afraid of the light. The more light the robot sees, the faster it goes backwards.